Hey there. I'm working at my Indiana State University, ISU, from Indiana State University. That's where I went to school. I live in Indiana, and I'm a proud Hoosier. I'm Mr. Chew. We're going to talk about dividing fractions in my tray arithmetic curriculum. And I want you to, very first thing, if these videos help you, give me a thumbs up and like it. Comment. Tell me what you think. Tell me if you like my hoodie. Tell me if you like my hat. You can subscribe down here if these videos help you. I'm doing this to help you. I spend a lot of time with my videos because I know that some students need help, and I'm willing to help you. So we had some challenge problems after I introduced my way of teaching the division of fractions, which you keep, change, and flip. In challenge 1, I said divide without using a calculator. So the first thing you do is keep the first fraction. So that's going to be 3/8. You just rewrite that. Then you change division to multiplication. Then you're going to flip or write the reciprocal. You have to do that before you can do anything. Now there's 2 ways to solve this. The first way is just to multiply across. The numerator is 3 times 2 over 8 times 1. But when you do that, you're going to get 6/8, which can be reduced. And the way that I was showing people how to do this was to write the numerator as a product of its primes. 2 times 3 is 6. And the 8, a product of its primes. And then you look to see if you have common factors in the numerator and denominator, because 2 over 2 is 1. So some teachers would say it cancels. It doesn't really cancel. You're just dividing by a common factor. You're really getting a 1 here, but when you multiply by 1, you get that same number back. That's why a lot of times the teacher won't write it. So it ends up being 3 over 2 times 2, which is 4ths, which is 3/4. Now, some people were taught in elementary, and there's nothing wrong with this, what's the biggest number you can divide 6 and 8 by? Well, it ends up being 2. That's called the greatest common factor. And if I divide the numerator, I have to divide the denominator, and it ends up being 3/4, which is the same answer. Well, why did you divide by 2 over 2? Well, right here. We just canceled those out by dividing by 2 over 2. Is there an easier way? Yes. What is the easier way? Well, the easier way is to take this keep, change, flipped multiplication problem and see if there's any common factors. 3 and 1 there isn't. They're called relatively prime. But 2 and 8 we can divide by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. Right there's the 2. Right there's the 2 that we just canceled. So it's going to appear in both. So this is 3 times 1 over 4 times 1, which is 3/4, which is the same answer I got all 3 ways. Hopefully you did that right. Did you? Comment. Let me know if you did it right. On challenge 2, first thing you have to do is change the mixed numbers into improper fractions. You take the denominator times the whole number plus the numerator. 5 times 4 plus 2 over 5. Divided by 20, the denominator, times 1 plus 13 over 20. So this ends up being 22 over 5 divided by 20, 33 over 20. Those are both improper fractions. Now we come over here and say, well, what do? We're going to keep, change, and flip. So I keep the first one, 22 over 5. I change division to multiplication, and then flip this. We change it to multiplication and flip, which means you write the reciprocal, 20 over 33. All right, now you can multiply across if you wanted to. The numbers are going to get big. But I want to emphasize, let's practice this finding the common factor in the diagonals. And when I say diagonals, it could be here, if it's not reduced, numerator, denominator, it just has to be in one numerator and one denominator. 5 and 20 have an easy common factor. What's a number I can divide 5 and 20 both by? Most people can see right away that it's 5. 5 goes into 5 how many times? 1. 5 goes into 24 times. Now this one's a little bit harder. What's a common factor of 22 and 33? Well, I can divide 22 by 2. I can divide 33, not by 2, but by 3. So what happens when I divide 22 by 2? I get 11. What happens when I divide 33 by 3? I get 11. I got an 11 both ways. So 22 divided by 11 is 2. 33 divided by 11 is 3. So now I'm going to multiply across 2 times 4 over 1 times 3, which is 8/3. Now, if it's 8/3, how do I reduce that now? That ends up being 8 divided by 3. So I take my 8 and divide it by 3. 3 goes into 8 2 times. 2 times 3 is 6. I have a remainder of 2. So my answer ends up being 2. The remainder is 2 over the divisor of 3. 2 and 2/3. How'd you do? Hopefully you did well. Hopefully you like this video. And if you do, give it a thumbs up and like it. Give me a comment. Say, Mr. Chew, that's a cool hat. Or I like that hoodie, Mr. Chew. Subscribe. Because those things, the likes and the subscribing, is what pushes my videos out to more people. There will be a link up here to get back to my original lesson where I introduce with examples before the challenge problems. Down here will be other tray arithmetic problems. Don't forget, I'm here for you. I spend a lot of time planning these videos and trying to figure out what you want to see, what you need to see. In the comments, tell me if there's something else that you need to see I haven't put on here. Subscribe to my channel and I'll put it on there for you. I'm Mr. Chew in Tray Arithmetic. Allow me to help you become a better math student. Mr. Chew wants to help you. I'll see you next time.